The real numbers, as a reminder, are the sets of rational and irrational numbers. And rational is any number that can be written as a ratio of integers, as long as b is not 0. Irrational can only be written as decimals that go on forever without repeating. So what's a good example of this? Well, how about 3.1211221122. Now, do you see a pattern? Yeah, you see a pattern, but does it repeat? You can get tricked into thinking that this is, but it's not. This is irrational. The more common ones are something like 7.89438201.5. You see, there's nothing at all that even vaguely looks like repeating. But sometimes we get tricked into it when we see a pattern like this. The book showed one like 0.134567891011121314. Again, this one's irrational. There really is no repetition. Even if there's a pattern, there's no repetition. And that's what we're looking for, is a repeated pattern, not just a pattern. Next, let's talk about square roots. Well, talk about square roots, it's easier, if we talk about squares, or perfect squares first. So, for instance, like 6 squared equals 36. So hopefully you're familiar with that. Anything times itself is a perfect square. 11 squared is 121. Things like that. I've asked you to memorize, you should have up through 12 squared already memorized. Hopefully you've already memorized 13, 14, and 15 at least. If you memorize 13 and 14 together, well, they kind of go together, 169 and 196. And then you know that 15's got to be over 200. And since you're multiplying a 5 by a 5, end in 25. So over 200 and ending in 25. So memorize those. Turning it around, what we're doing is we're saying, okay, what is the square root of 36? Well, what we're saying is, what is one of two equal factors that make up the radicand? Well, that's something else. We need to go over some vocabulary here. So the square root of 121. Well, this symbol, we call it the square root symbol. It actually has a name. It is the radical. It has even a very cool name, doesn't it? What's underneath it is called the radicand. Not as cool. And it is read the square root of 121, or you can actually say radical 20 or radical 121. So that is a proper way of reading this. One way to show our work here, to show one of two equal factors, is to say, well, 121 is equal to the square root of 11 times 11. And so what's one of those two equal factors? Well, it's 11, right? Something I want you to watch out for is something like the square root of 0.49. Hopefully you can see that that is going to be 0.7. So it's not a perfect square. We don't by any means call it a perfect square, but it does have a square root that is not irrational. Most square roots are irrational, like the square root of 2, that would be irrational. The square root of 12 will be irrational. The square root of anything that's not a perfect square, but these are like sleeper square roots. How about the square root of 1.96, right? That's going to be 1.4. So although it's not a perfect square, we don't want to call it that. It's also not irrational. So now we should know what to do with an equation like this. X squared equals 225. Well, anytime we solve an equation, we want to do inverse operations. Well, the inverse operation, how do we unsquare something? Hopefully you guessed it, that we square root it. However, we have to be really careful here. Here, it's saying what number times itself equals 225. Well, x will equal 15, but it could also equal negative 15. See here, there's a difference here, and you want to be aware of it. The square root of 225 is just 15. The only way to get negative 15 is if it asks you what is the negative square root of 225, or what is the opposite of the square root of 225. Well, that is negative 15. But whenever we have this situation with a variable squared, let's say h squared equals 81. So again, we want to square root each side to solve for it, but h can either be 9 or negative 9, because when we plug them back in, that's one way to check it, right? Whenever you have an equation, you can check it. Well, does 9 squared equal 81? Yes, it does. And really, we're squaring 9. The only reason I show you that is because now if we're going to check negative 9, it has to be in parentheses. And yes, that also equals 81. In your calculator, if you check this, negative 9 squared without parentheses, it'll tell you negative 81. So be careful about that, because in this case, this is showing that the root, or the base is 9 only. If you want the base to be negative 9, you have to put it in the parentheses. I want to say one more thing about this, and that is that you can write your answer like this: h equals plus or minus 9. This means we're saying that both a positive and a negative 9 satisfy the values for h that equal 81, but that when you square it, equal 81. So as a quick check, the square root of 0.25, you can put in your calculator. It's going to tell you 0.5. I love doing mental math here, but a lot of times students want to say that equals 0.05. Remember, if we square that, that would actually, if we squared 0.05, that would equal 0.0025. So be careful about mental math. How about the square root of negative 25? Well, if we break that down, the square root of 25 would equal negative 5 times 5. Are those two equal factors? No. So right here, this is not a real solution. How about g squared equals 0.25? So we would square root both of these sides, and g would equal plus or minus 0.5. Again, you can write them separately. So you could write it as 0.5 or negative 0.5. So you can either write your solution like this or like this. And then for k, I don't know why I had to squeeze these in here, but square root both sides. And again, what you would say is k equals no solution. Well, you can say no solution for now. The real answer is no real solution. This is where we get into imaginary numbers, the square root of a negative, but that's for another time. So now I need to teach you how to estimate square roots. So whenever we have a square root that is not a perfect square root and they want us to estimate, what we do is we figure out what it's in between. So think about it like on the number line. Where is the square root of 18? Well, I know that the square root of 16 is right next to it, right? And that's 4. And then the next one, which would be 5 squared, is 25. So I know it's between 4 and 5. So one way of writing that is the square root of 18 is between 4 and 5. If we want to get a little more, exact, if we want to estimate, like with a decimal, 18 is only root 2 away. I mean, not really supposed to subtract, but can you see how it's closer to square root of 16? Because it's like only root 2 away from square root of 16, and it's like root 7 away. So there's a difference of root 9 in between these, and it's much closer to the 16. So then that's when you start to get a feel for things, and you say, well, I would estimate around a 4.2. And I just did on the calculator, it's 4.24264068, and of course it's an irrational number, so I kind of looked out. I actually thought it might be a little bit below, more like 4.18. So, I mean, this is a good decimal estimate, but I really think this is what the book wants you to be able to do, is to figure out which two integers it's between. So let's take another one. How about like the square root of 55? Let me think of the two perfect squares right around 55. Right above it, it seems like the square root of 64, and right below it, the square root of 49. So I know that 55 is between, the square root of 55 is between 7 and 8. If I wanted to approximate the decimal, I can see that it's about root 6 away from 49, and it's root 9 away from 64. It's pretty close to the middle, so I would guess 7.3 or 7.4. Now, if you're allowed to use your calculator, obviously you can figure out which one it is, but I like to be able to do some mental math. All right, next we're going to talk about cube roots. So for instance, something like the cube root of 27. So we already know that this symbol right here is called the radical. What's underneath is the radicand. Well, you need to know that the number that's out here, and that's why there's this little table right here. You've seen that most square root symbols have this little table. Well, if it doesn't have anything there, it's an understood 2. You can also write the 2 if ever, you're in doubt, or someone can write the 2 there, but we usually don't. If it's blank, it's a 2. That's why we call it a square root. This one is a 3, which means it needs 3 equal roots. And we're just going to say, okay, that right there is called the index. It's a vocabulary term you need to know. So what we're saying is, what number times itself 3 times equals 27? Well, I know that 27 is 9 times 3, or 3 times 9, and that 9 is 3 times 3. So I know that the cube root of 27 is 3. And I can extend that to the idea, if you'll remember, that like if x cubed equals 27, well, the inverse operation is to cube root both sides. And x would equal 3. Now, does it equal 3 or negative 3? Well, let's check it. 3 cubed, if you do that on your calculator, that equals 27. What about negative 3 cubed? Do you see that it equals negative 27? So here we don't worry about plus or minus, or that there aren't 2 answers right here. There's only 1. So the cool thing is we can even have a negative cube root. Let's do one up here in the corner. So what is the cube root of negative 64, I think, is 1. Yeah, this one equals negative 4. So to give myself a little room here, if I had x cubed, or let's use a different variable, if I had y cubed equals negative 64, there is an answer to this, because of course to undo that we would cube root both sides, and y would equal negative 4. Only one answer. If they're going to get tricky with cube root decimals, this one would have to be like 0.064, and that would equal 0.4, because now you're multiplying 3 decimals together, so you would have to have 3 places past if you started with 1. But let's look at the cube root of a not perfect cube, like the cube root of 17. Well, if I want to estimate that, I know it's got to be between the cube root of 8, because that's 2 cubed, and 3 cubed was 27. So I know it's between 2 and 3. But remember, it is an irrational number. Anything that doesn't come out to be an exact decimal, a terminating decimal, or an integer is irrational. And this chapter talks a lot about, is it irrational or is it rational? This one would be rational. This one would be irrational, and we can estimate it. I really don't know. I mean, that one's 11 away and that one's 10 away, so I would guess around 2.5. It's really, really close to approximately 2.5, but that's an approximation. This is still an irrational number.